Hey guys, and welcome back to a video series on balancing equations. These are some extra problems that if you're actually a part of the course that I'm kind of doing here, these are some extra problems that I thought you might get stuck with in homework. And if you're not part of the course, these are just some that I thought might be a little harder and some good examples. So if you're looking for practice, go through, pause the video right now, solve this problem, and then check your answers as we go through. You can kind of fast forward a little bit if you need to. So let's kind of get to going here with these problems a little. So I'm going to go to black for doing this. So let's start off and let's complete our T. So we've got Mg, we've got nitrogen, we've got oxygen, we've got potassium or kalium in the Latin, if you're wondering why it's K. We've got P and then oxygen again, but we've already wrote it down, so no need to do it twice. Now, I'm going to go ahead and just default write these in the exact same order. Some people don't do that. They kind of just, I like this because I write big, so it helps me like lose track of or keep track with everything I'm doing. So magnesiums, I've got 1 on the left. Nitrogens, I've got 1 in parentheses, but that really means 2 times 1. So 2 nitrogens. My nitrogen looks a little almost like a wolfram there, so I'm going to fix that as well. Now, oxygen's where somebody will get lost. 2 times 3 is 6. 6 plus 4 is 10. Now, let's look at that potassium. There's 3 potassiums and 1 phosphorus. Well, while we're at it, now move to the right side. Magnesiums, we've got 3. Nitrogens, there's 1 we see. Oxygens, do some addition. So 2 times 4 is 8, plus the 3 means they're 11. You're probably looking at it like, oh no, well, don't even worry about it. Potassium, we've got 1, and phosphorus, we've got 2 times 1 is 2 phosphoruses. Now, this is a case of which one do we start with, should be your concern at this point. Well, I taught you a little trick before. I said, start with the one you see the least in the problem. So I see magnesium twice. Okay, so I'm going to put a little 2 out here. I see nitrogen. I see it twice. I'm not actually counting atoms. I'm literally counting how many times I actually just see the letter N. Oxygen, I see it 1, 2, 3, 4 times. And then potassium, 1, 2. And phosphorus, I see 1 and 2. So there's 2 times I see phosphorus. So Mr. Cole, you've basically helped us none. Oh no, I have helped you. I've let you know, do not even try to balance that oxygen, the 10 and 11. Don't even worry about that. So what we're going to do is go any, mini, money, mo, catch a tiger. I'm joking. Literally, what you need to do in this situation is just pick one. Like for me, I'm going to pick Mg. And I'm going to go ahead and work it out using Mg. And the thing is, if it becomes this massive pain in the rear end, I'm just going to start it all the way back over to here. And I'll pick like maybe K to start next time. If that becomes a pain, I'll start with P. You'll be shocked. Usually if you start one and you're unable to balance it, if you'll just start over, you'll probably fix it really fast, really easy. So especially on an exam, don't take a bunch of time if you get stuck. Just go ahead and start over and pick a different one. So we've got 3 mg's on the right. So I'm going to put a coefficient of 3 in front of mg on the left. So that makes 3 times 1 mg's is 3 mg's. Let's see, what else does that do? Well, that's really 2 times 1 n. This is what people always forget this. 2 times 1 n is, so that's really 2 nitrogen. So 2 nitrogens times 3 is, now we're at 6 nitrogen. Let's see what else we got. 2 times 3 is 6. 6 times the 3 is 18. Plus 4 is, see, we're already at 22 on the oxygens. So now you got to pick what you want to balance next. Well, if it's me, I'm going to just go down the list. We've got this 6 for nitrogen on the left. Let's go get 6 on the right. So I'm going to put a 6 in front of the potassium on the right side. So remember, that affects K, N, and O. So 6 times 1K is 6. 6 times 1N, 6. 6 times 3 is 18 oxygens. plus this 8 is, oh, good grief. Are you kidding, Mr. Cole? 26? Yeah, I'm not too worried about it. So let's keep going. Let's pick potassium next. We've got 3 on the left and 6 on the right. So we'll multiply this side by 2. 2 times 3 is 6 Ks. 2 times 1P is 2 Ps. 2 times 4 is 8 O's, plus if you remember, we had this 3 times 2 times 3 is 18. Wait a minute. And lo and behold, this equation's balanced. All right, so moving on. I'm not going to spend a lot of time on these. Sometimes you'll see an equation. This is kind of like how they write them out in organic chem. And if you see this and it looks like this massive pain in the rear end, I'm not even going to balance this. I'm just going to teach you a trick for working it. Do this. When you see that organic chem style, condense this and it makes it easier. So instead of CH3COO, and this is really just acetate is all it is, it's just written out all wonky. Condense it to C2H3O2 and the problem will be easier to work. So there's a little hint for doing one like that. Because you'll see some of that organic style writing, and that's all you have to do. Same thing on the right side. Where it says Na sodium, CH3, it's just sodium acetate. Just condense it, C2H3O2. And you're probably wondering, Mr. Cole, why would they even write it that way if it makes it harder? Just to confuse kids like you. Come on, let's keep going. Let's throw this guy in here. This one's a little bit more of a challenging one to have to work. If you actually get into this one, you'll probably hate me for it. But I'm going to do it for you anyway. It is a little bit more of a challenging problem, and it may even, I haven't worked it in like years, so I might get like stuck on it. We've got SN, we've got 10,2 oxide. Actually, that's 10,4 oxide. Get it? 10,4, good buddy? Remember, oxygen is a -2, so that has to be 10 with a +4. Now that we've got that out of the way, we've got NO, see if I can draw it better, N, H, and O again. So it's kind of funny, as big as this problem is, there's only 4 elements in it. And so we better have the same 4 elements on the other side of the equation. And this is probably going to be one that's just a pain in the butt because we've got like O in 4 places. We've got H in 2, N in 2. So again, we kind of have a little idea where we're going to go here. So SN, we got 1 on the left. O's, we've got 5. N's, I've got 1. And H's, I've got 2. So slide to the right side, we've got 1. Hey, it's balanced. O's, we got, oh no, only 3. N, we've got 1, and H's, we've got 1. Hopefully you've been racing me on this one, and you're like, I've already got it, Mr. Cole. I've nailed this. Well, you're going to probably end up stuck with something, because chances are you're going to go through, you're going to go, all right, Mr. Cole, I learned your trick. I'm not going to do O, so I'm just going to start with H. And so I'm going to go up here, and I'm going to put a 2 on the right side, and I'm going to get started balancing this. Okay, let's do it. So 2 times 1 H is 2. Cool. 2 times 1 N is 2. 2 times 3 O's is 6, which actually I like the 6 because that feels more even. So now let's slide over to the other side. And so let's try and do the nitrogen next. So your gut instinct would be, well, if there's 2 on the right, let's slide a 2 over here. And we'll go 2 times 1 N is 2. Yes! 2 times 2 O's is 4. 4 plus 2 is 6 plus 1 is 7. We are still having a miserable time, Mr. Cole. So we're still kind of stuck, and now we've got this impasse. We've got this 7 and 6, and everything else is balanced. So Mr. Cole is going to teach you the final trick in the playbook. That's right, the last trick. If you get completely flabbergasted beyond all measure, do this. Go back to the beginning, double one of the numbers you started with. I know it seems like, Mr. Cole, are you serious? Of all the stuff you do, So I'm just going to undo, and I have that advantage because I'm on a computer screen. Undo, undo, undo. I started with a 2, so check this out. Now I'm going to start with the number 4 and see if this last trick in the tool belt works. So I've got 4 H's. I've got 4 times 1n is 4. And you're probably sitting there going, Mr. Cole, there's no way this works. Oh, well, let's just find out. 4 times 3 is 12. And now let's go to the other side and try and balance this thing out. So I've got 4 H's on the right and 2 on the left. So let's throw a 2 in front of that H2O. So 2 times 2 is 4 H2Os. I've got, ooh, this is crazy. 2 times 1 is 2, 2, 2. I'd like to wear my tutu. I'm just kidding. I don't own a tutu. Or maybe I do. Anyway, next, take a look. Let's do nitrogen. We got 4, so let's multiply this side over here by a coefficient of 4. 4 times 1n is 4. 4 times 2 is 8. Wait a minute. 2. Oh, you gotta be kidding me. He did it. 12. And that equation is balanced. I'm going to check this video because they're really only going further. I love that, though, teaching you that one last trick. Let's do one more. Wow, I don't even have the one I wanted to do. These are some word equations. You know, I'm not really interested in doing a word equation unless somebody asks me to. I do want to do one example of where like something's being burned. Let's do propane. C2H8. And this is from organic chemistry. And to burn something, we need oxygen. And what's cool is when you burn it, you make carbon dioxide and water. And I wanted to throw this at you because these always end up, every time you work them just about, I don't know if this one will, but it seems like they usually end up with like usually end up like something and a half. So like something and a half is usually like magic for these. And again, if you have this teacher who's like, I forbid you to do that, just when you get done, multiply the entire equation by 2 and they'll get rid of your half. And you'll make that person happy with themselves because they have obviously way too much free time. By the way, propane has actually got 3 carbons. Prop means 3 in organic chem. Eth means 2. Hey, if you're curious, watch my organic chem videos. So here we go. I'm just going to do this instead of using my pretty ones. CHO. CHO. Go quick, Mr. Cole. 3, 8, and 2. And on the right side, you should be racing me right now. What are you doing? Pick up the pace. Finish the problem. Don't let me beat you. And 3. And so chances are what you want to do in this problem is you're like, there's 3 on the left, so I'll put a 3 in front of the C on the right. Cool, I like that. So there's now 3 C's on the right. I'm going to change up my colors so that I'm kind of not doing. So there you go. There's now, all I've done is make it worse. Good grief. It's a long day. So I've got 3 C's. I've got 3 times 2 is 6 O's plus 1 is 7. You're probably, Mr. Cole, you're really just wrecking this for all of us. Hey, give me a break. Let's see. H. I've got 8 on the left. I've got 2 on the right. So how about this? Let's just multiply that by a coefficient of 4. 4 times 2 is 8. Fix that. And now I've got, oh my goodness, this one comes out perfect. I should not have picked propane. 3 times 2 is 6. And then I end up with 4, which makes 10, which makes this as easy as add a 5 and bam. I don't know why I just marked out that 8. That 8 can stay. It's the O that's now 10. And that's still 8. Well, I had like this awesome video and I just totally screwed it up and I don't feel like editing it. So anyway, now that's 10 and I've probably just like infuriated you by not starting this video over. A lot of times you'll work these problems though. I'm just giving you this heads up because you're going to run into it. And you're going to end up with like O2 yields CO2 plus H2O. And you're going to end up getting everything said and done, and you're going to end up with like 13 oxygens on the right side. And you're going to be like, how can I get 13 over on this side? Easy. Just multiply by 6.5, and you fixed it. And again, my teacher doesn't like me to do that. So change that to 13 halves, and then go through and multiply everything by 2 and cancel it out, and it'll work. So that gets you around that person that doesn't like the halves. And again, I know why they don't like the halves. It's from the standpoint you can't have 6.5 oxygen molecules. That's the reason why they're like that. But the fact is, when you start doing your stoichiometry and stuff later on, it's not going to make a difference. The 6.5 will work just fine when you solve for your problems. So anyway, until next time, this is Mr. Cole saying have a great weekend. Unless, of course, you're watching this video on a Monday and, wow, that really stinks. But bye. Bye.